My geometry PBL project is based on a Greek philosopher and mathematician known as Pythagoras. Pythagoras lived from 570 BCE to 495 BCE. He was characterized as an intellectual superiority in his ancient Greek town. The Pythagorean theorem was not introduced by Pythagoras, but rather was proved by him. Pythagoras was a part of a group named the Brotherhood of Pythagoreans, where he developed many numerical theories and where he gave many numerical values to objects. This led to him being very intuitive about math and further proving the Pythagorean theorem, which is named after him. Legend has it that upon proving the Pythagorean theorem, Pythagoras sacrificed 100 oxen. What is a right triangle? It is a triangle that has a 90-degree angle. The two sides opposite to the non-90-degree angles are legs, and the side opposite to the 90-degree angle is the hypotenuse. The hypotenuse is always the longest side. In the Pythagorean theorem, A and B are the two legs, and C is the hypotenuse. A and B can belong to either of the legs, but C always corresponds to the hypotenuse. These are examples of how the Pythagorean theorem can be used to find the hypotenuse of either of the two legs. The Pythagorean theorem can also be seen in the spectrum of real life. It can be seen in pyramids, buildings, and many other structures. The Pythagorean theorem is perhaps the most powerful mathematical equation used in the building trade. Using it, drawings can be enlarged, foundations can be laid out, and perfectly square angles can be calculated. It can be used by everyone from surveyors who want to find out how tall a mountain is, to astronomers who want to calculate the distance to the sun or the circumference of the moon. Carpenters can use it to keep their work square. Draftsmen use it to make their architectural drawings accurate. The Pythagorean theorem can aid in studying and understanding maps as well as distances between points on a map. The Pythagorean theorem is applied while using the grids on a map to find distance and then converting it by means of scale to understand the actual distance between 2 points. A simple way to prove the Pythagorean theorem is by taking the shapes as seen above and moving their respective triangles to show that a squared plus b squared equals c squared. The Chinese people also used the Pythagorean theorem a while back in around 1000 BCE, but did not necessarily know how to prove the theorem. But eventually, Pythagoras was able to prove the theorem, which is why the theorem was named after him. Special types of right triangles create Pythagorean triples. A Pythagorean triple consists of three positive integers, a, b, and c, such that a squared plus b squared equals c squared. To prove the Pythagorean theorem, I cut cardstock paper into the shapes of 4 small right triangles and a large square using scissors. I placed the triangles over the square as seen on the picture to create a square labeled c squared. This represents the area that the hypotenuse of a triangle would take up when it's squared, as in the Pythagorean theorem. When the triangles are moved accordingly, the same amount of area is produced with a squared and b squared, which should represent the legs of a triangle. This shows that a squared plus b squared does equal to c squared as proven by Pythagoras. All in all, the Pythagorean theorem was proved by a philosopher known as Pythagoras and expresses the side length of a right triangle when two are given. There are also Pythagorean triples such as 9, 16, 25. The Pythagorean theorem can also be seen in real-life monuments such as pyramids or structures like buildings.